So this evening, we're going to talk about intercepts, which is x-intercepts and y-intercepts on a graph. So what are intercepts? Well, the x-intercept is the place where the line crosses the x-axis. The x-intercept is the place where the line crosses the x-axis. It's also the place where y equals 0. The x-intercept is where y equals 0. Just like that, the x-intercept is where y equals 0, yes. So the y-intercept is also the place where the line crosses the y-axis. Y-intercept, place where the line crosses the y-axis, is the place where the line intercepts or intersects the y-axis. It is also the place where, or the point where, x equals 0. So the x-intercept is the point where y equals 0, and the y-intercept is the place where x equals 0. So if you have, let's say, 0, 4, and -3, 0, well, this one is the y-axis or the y-intercept. Let me see that? Yeah. And this is the x-intercept. Y-intercept, because the x value equals 0, and then y equals 4. It means the y-intercept is at 0, 4. And the x-intercept is at -3, 0. You can use standard form to find the intercepts. You can use standard form to find the intercepts, It's one thing to say it, and then when you get ready to write what you said, the words don't want to go together. Use standard form to find the intercepts. So let's say we have 3x minus 4y equals 12. 3x minus 4y equals 12. We can use the cover-up method. And it's called the cover-up method because you just cover up the one you're not trying to find, the value you're not trying to find. So when we want to find the y-intercept, we cover the x. Cover the x. So if you cover the x, let's say you cover this, you're left with -4y equals 12. And then solve for y. Cover the x and solve for y. We divide both of these by -4, divide by -4, and you're left with y equals -3. This is your y-intercept. Okay, and if you do the same thing with 3x minus 4y, and to find the x-intercept, you cover the y, solve for x. Okay, so we cover the y, this whole thing here. You can't really see that. Cover the y. If we did that, then we're left with 3x. Here we are. We'll cover the y here. We're left with 3x equals 12. If we solve for x, we divide both by 3. So we're left with x equals 4. This is our x-intercept. You find those two, you graph them on a coordinate plane, and there you go with your intercepts. Okay, let's see if we want to graph those. Well, do we want to graph those? Trying to decide if I'd like to do that. Let's see. Well, we've got the y-intercept here is -3. Our y-intercept is -3. Let me see that. Nope. Y-intercept is -3. And I need to move this down. So there we go. And the x-intercept is +4. X-intercept is 4. Put our point there. The y-intercept was -3. X-intercept is +4. Take these two, connect our points using our ruler. My husband gave me this ruler. Use our ruler, and there is our line based on the intercepts, those two intercepts we just found. Okay? You also can graph just by using intercepts. Let's say you were told what were the intercepts. If you were told that the x-intercept is, -2, and you were told that the y-intercept is +4. Again, you can take your graph. See if there's a graph here we can use. You can take your graph and plot those 2 points. We're plotting the x-intercept of -2 and the y-intercept of +4. Use your ruler. Connect your dots. And there you go. My line looks kind of crappy there. Got kind of thick. There's your line given the intercepts. So the question is, where would we use intercepts in the real world? Like, what kind of graphs would we use in the real world for x and y intercepts? X and y intercepts. Well, let's see, for example, if you were if you had a gym membership, and the gym membership said it's $5. Let me see, real world usage. Because the kids always want to know, when am I ever going to use this in life? Let's say you have a gym membership and it costs $5 to start. Let's say someplace like Planet Fitness is running a special, and it's $5 to start, and it's $10 per month after that. Well, this can be shown on a graph. I probably need a bigger graph, but this can be shown on a graph. Let's say you had one. I'm going to draw my own. 5, 10, 15, 20. But I'm going to do these in ones. Okay. So you're starting with $5 to start with. So this is like the months here for each month is there. So at 0 months, it's $5. Even if before you start, it's $5. But it's $10 more per month. So every month, so on month 1, we're going to pay $10, but we've already paid our $5, right? So now we're at $15. By month 2, we'd be up to $25, and it would go on from there. So if you had this, you would draw this line starting here and going up, because you don't need it to go past the 0. That's all you need is that point there. There's no negative amount of months, right? This is our 0 month. So this is how much money you will have spent after each month. After 1 month, you have spent $15. After 2 months, you have spent $25 because the first $5. So this would let you know that the registration fee or whatever would be $5. Another one, let's say, for example, would be the entry at the fair. Maybe it costs $10 to get in, but the tickets are 50 cents. The tickets are 50 cents each. Okay, you'd have a graph here also. Again, there's no reason to have these down here because you don't have a negative amount of tickets. So let's say we start here with $10, and then we go up in increments of $1. This, this kind of shows this little broken line here, lets you know that there's a little delay or break in the thing. And this is the number of tickets that you buy. So the first entry, if you don't buy any tickets, it still costs you $10. After you bought 1 ticket, you've spent $10.50, and 2 tickets, you're at $11. 3 tickets, you're at $11.50. On up from there, you're at $12, and you would connect this line. The more tickets you buy, of course, it continues to go up. Another use could be, you started off at 150 pounds, and every month that you work out, you drop a pound or 2 per month. Then the 250 would be the first starting place, and then you'd go down or decrease every month as you lose weight. Okay. So now we've talked about the intercepts. We've talked about how they can be used. We've talked about how to find them. What would they look like on a graph? Okay, if you're looking at, let's say this graph here, I'll put this under a clear piece of paper. Looking at this graph here, and you were told to identify the intercepts. Well, you can see that according to this graph, the x-intercept is 5. It would be 5, 0. And the y-intercept is here. And it is 0, 3. Just by looking at the graph, it's the places where these graphs cross the x and the y axis that are the intercepts. Okay? If this video has been helpful to you, then subscribe to the channel so you can be notified when new videos are posted. Also, visit us at 8minutemaths.com, where you can see our content and resources and courses, things that are available to you there. Lastly, follow us on Facebook at 8minutemathshelp.com. We look forward to seeing you there.